Okay. All right, so today is pretty much a review. We're going to look at composite functions again, and actually just functions in general, and then writing equations, which we've done 3 or 4 times. So that should be a review as well. All right, so let's start with, let me give you 2 functions. So example 1, okay, f of x equals 2 minus x cubed, and g of x equals x cubed plus x squared minus 3. Okay? And so we have these 2 functions. And actually, this is not going to be a composite function. A composite function is like f of g of x or even g of f of x. This one, I just want you to perform an operation on the functions. Let's say I want you to, and we're going to sketch it, so I'll put sketch. We're going to sketch the graph f of x plus g of x. Okay, well, this is literally, we're adding these 2 equations together. All right? So I will write it out. So it's just f of x, 2 minus x cubed. And it says we're adding g of x to it. So plus, well, here's our g of x. So x cubed plus x squared minus 3. So we want to graph that thing. Well, is there anything we can do before we graph this? We can combine, there we go, combine like terms. So we got negative x cubed plus x cubed, that's gone, right? That's 0, perfect. And so f of x plus g of x equals, let me put my variable first because that's the way we usually see it. It's in descending order. So we have x squared. What do we have? X squared plus 1 or minus 1? Minus 1. 2 minus 3, so minus 1. So that's the function we're going to graph. So all we do is add it. We add it and add like terms. So let's, and we all know that this thing, does it go left 1, right 1, down 1, down? Just goes down 1, right? So in our quote parentheses, which there aren't any parentheses, so it doesn't go left or right, but it goes down 1. So there we go. There's our vertex. That's how it shifts. And then how did we graph our parabola? We just opened up like this because it's positive, or what did we have to do? Yeah, let's pick another point. So what's another point we want to pick? Positive 1's a nice easy one there. All right, so 1 squared is 1. 1 minus 1 is 0, and that's nice and easy. 1 comma 0. If we had to pick another one, x equals negative 1. Let's pick another one as well. Negative 1 is fine. Let's pick 2. All right, so 2 squared is 4 minus 1 is 3. So 2 comma 1, 2, 3. Get a little bit better idea what the shape is. And we can pick some negative numbers as well. But here's our parabola like this. Symmetrical on the other side. Yes, Jen? Okay, and there we go. Okay. Okay, number 2. Let's say we have f of x equals negative 2, parentheses, x plus 3 squared, and g of x equals negative 4. Okay, so let's do this. Let's do f of x minus g of x. Still pretty easy, I think. And we'll sketch this one. We'll sketch it. Okay, f of x minus g of x. Well, let's start writing it. Okay, so f of x, negative 2x plus 3 squared. So what do I write now? Good, it's really going to be plus 4, right? Because it's minus, I'll write it though. Minus what? Minus g of x, which happens to be negative 4. And what's minus a negative? that's plus. Okay, nice and easy. All right, so we can sketch this. We've sketched this many times. All right, so it goes which way and which way? Left 3 and up 4. 1, 2, 3. Left 3, up 1, 2, 3, 4. There we go. So left 3. We know it opens down. Let's pick 1 or 2 more points. So what's a good one to pick? -2. I usually go 1 away from that. Sure. We're at -3, so -2. And then most of you guys can do this in your head. So -2 plus 3 is 1 squared is 1 times -2 is -2. If you keep all this straight, so -2 plus 4 is +2. So that's what you plot. -2, comma 2. There we go. We could also pick -4. We'd probably be at 2, but let's just go with that. Okay. There's our graph. Okay, let me do one more like this. Actually, let me do a composite function. Okay, so number 3. Okay, f of x equals 4 minus 2x squared. This is like on the back side of yesterday's homework. And g of x equals x plus 5. Okay, we're going to sketch f of g of x. And actually, since we know how to do this, go ahead and see if you can write out what f of g of x is and then graph it. And then I'll call on someone to help do that. All right, so go ahead and write what f of g of x is, and then sketch it, and then sketch. Okay? F of g of x. Write that out. And then sketch. So we've done a problem like this before. I want to see if you remember how to do it. Or just the x plus 5. So where do you see that's what so you just fill in the thing. I thought we filled it in the oh, okay. Let's go into the or the no, keep the -2 because it is put it 4. If you want to take 4, you can do that. Because that makes it go less. It does that. So if you want it, it goes there. Just and I probably would. And I was before, which then the graph. Okay. Okay, let's Austin. Okay, Austin. So f of g of x, do you know how to rewrite that? So what do we do? Okay, I'm not going to combine it, but let me start it like this. So it's f of, well, g of x is x plus 5, right? So f of g of x, so it's f of x plus 5. Okay, and do you remember how to write what f of x plus 5 is? Okay, can someone else help? How do we? Faith, do you remember? Give it a shot. So,
well, I'm just plugging that into the x of x.
yeah, right there. That's what we do. So f of x plus 5, well, we plug into our f of x, we put x plus 5 there. Okay, so f of x plus 5, it's going to be 4 minus 2, and then, yes, plug it right in there. So x plus 5 squared. So that's f of g of x. F of x plus 5. So wherever you see it x, put x plus 5. Okay, do we see that? Okay. Just like if I said, what is f of 7? You'd plug 7 right in for x. Right? 7 squared is 49, blah, blah, blah. Right? Okay, so then we want to graph this. Right? Well, you can leave it like this, but we're used to seeing the number on this side. Well, actually, before I do that, can I subtract? Can I go 4 minus 2 is 2? And so that's 2. We can't. We can't. Because the order of operations say we have to multiply first and then add that. But, you know, there's really nothing to multiply your number and your variable. So we just, pretty much it's like that. We cannot subtract 4 minus 2. Okay? But what we can do is this. Let's just take this positive 4 and put it to the other side, because that's the way we're used to seeing it. So it's negative 2, parentheses, x plus 5 squared. I just rewrote that. But I'll just put this plus 4 on this side. Okay? And so this, same thing. Same thing. It's a little easier for us to see, right? As far as how we shift it. Okay. So, Thomas, how does this thing shift?
Up 4, left 5.
There you go. Goes up 4, left 5. Okay, so that's what we graph. So 1, 2, 3, 4, 5 to the left. Up 1, 2, 3, 4. There we go. And then it opens down. Opens down, right? So, Sydney, how do we get another point? Or what should we plug in? So if it opens down, let's pick another point, x, y. Sure, let's pick negative 4. Okay, so negative 4 for x. Let's see where we're at. So negative 4 plus 5 is 1. Right? Negative 4 plus 5 is 1. Squared is still 1. Times negative 2 is negative 2. Negative 2 plus 4 is negative 4 plus, or excuse me, negative 2 plus 4. Positive 2. Positive 2. So negative 1, 2, 3, 4. 1, 2. There we go. So we shifted the vertex. Okay, Sydney shifted the vertex. Picked another point. Sydney picked that, and there we go. There we go. Okay. Okay. Okay, this is why we can't, some are going, well, still, why can't I just subtract that? 4 minus 2. What if we had this? 5 minus 3 times 4. Actually, go ahead and write this down. Just put it anywhere where you have a little bit of space. If I give it to you like this, we kind of know we can't just call that 5. We can't go 5 minus 3, can we? We can't just say, hey, that's 2, and then times 4 is 8. No, because it's not order of operations, right? what would you have to do first? Yeah, that's 12. And 5 minus 12 is whatever, -7 is the actual answer. That's why we can't just go 4 minus 2. Okay, does that make sense? All right. Okay, so let's look at this, I have to review writing equations. So I have this worksheet, and we're not going to do them all, but let me pass this out, and then we're going to do a couple off of here. So it's still on our notes, but I don't want you to have to recopy graphs. So take one, pass that. Three, and one more. Nope. All right. So great review, because we sometimes forget. All right, so writing equations. Let's kind of review this. All right, let's start with number 1. We'll do a line, we'll do a parabola for sure, we'll do one of each, and then maybe we'll do one, maybe or two on the back. Let's see. All right, so let's look at number 1. So it says identify domain and range, and then write the equation. Well, let's do domain and range first. Okay, yeah, all reals. If you have a line and it's got some kind of slope to it, all x's are covered and all y's have a graph to it. So domains -infinity to infinity, and the range of heights, because there's a tilt to it, it's going to go low and it's going to go high. So that's -infinity to infinity as well. So that's our domain, that's our range. So the equation, it's a line. It's got a slope to it. Let's figure out the slope first, because we know we need it anyway. So to go from this point to this point, what is our slope, if you can help? 8 over 6. So up 8 over 6, okay, which reduces to 4 over 3. Okay, so slope is 4/3. So y equals 4/3, y equals mx plus b, right? We did this a couple ways, because with a line, you could pick any one of these 2 points to make your equation. Just pick one of the points to make the equation, not both at the same time. Let's pick this one. And we put the shift, which we're good at now, I hope, and we've got our equation of our line. So normally it's at the origin, but let's use this point. So this shifted, how did it shift? How did it shift? Okay. Well, this one, so left, to get this, left 1 and down, what is that, 5? 5. So left 1, down 1, 2, 3, 4, 5, down 5. So let's write the equation. So if we go left 1, how did we write that? X plus 1. So that's left 1, and then down 5. And there we go. Don't put a square there, because that'd be a parabola, right? There's your answer.
That's kind of what I was talking about earlier. So you would put the round brackets though instead of the straight line for that, for the x plus
Yeah.
Is there a difference between that?
Yes, if it's a like absolute value, if it's straight lines, and that'd be a v. That'd be a v. Yeah. All right. Let's say, just because we can and it's pretty easy, let's say we used this point. Okay, we have same slope, y equals 4/3. This shifts from the origin 1, 2, 3, 4, 5 to the right, up 1, 2, 3. 5 to the right, up 3. This would be 5 to the right. X minus 5 to the right, it's like that, and then up 3. Either one of those is correct. Okay. If you distribute this, it ends up being the same exact equation. You can give me this on the test for an answer. You can give me this as an answer on the test. Okay. Yeah, you could simplify it and give me that as well, as long as it's the same thing. Okay, so that's how you do a line. Do we remember that? You remember doing that way? Yeah. Okay. All right, parabola. Let's go to this type. This one, we don't have a choice as far as, we're going to, as far as how it shifts, always the vertex. Always the vertex. All right, so let's start writing. I'll do domain and range after. So y equals, well, we don't know the stretch, right, that a number, so I'm going to put a. But we do know how it shifts. This is 3 to the left and 1 down. Okay, 3 to the left, 1 down. We could do that. So 3 to the left. So x plus 3. Don't forget to put squared because it's a parabola. So left 3, down 1, so minus 1. There we go. How did we get the point? Or excuse me, the a? Plug in that point. Well, what is this point? The point is at negative, where is that? Negative 1, 4. There we go. And that's what we plug in. Okay, don't plug in the vertex. It's just not going to get you anywhere. So plug in a point that's not the vertex. So let's go ahead and plug this in. So that's your x, that's your y. So 4 is your y. So 4 is equal to a times negative 1 plus 3 squared minus 1. And go ahead and finish this. I want to see if we can do our arithmetic. And I'll call on someone. So finish getting our equation. So finish the arithmetic there. And get the a value. And then rewrite the equation. And rewrite the equation. Let's see if we get our a value correct. All right, look at the person next to you, look at what they got, or look at someone, kind of compare, you have a different answer. Try to figure out why.
I got one.
To get rid of the 4, yeah, you would. You have this one. Can't simply have So, okay, attention back up here. It seems like we're a little confused on this. Some got it. Some got it. Very few got it. But let me start writing this because that's what I saw in your papers, which is okay. We have 4 is equal to a, and then you ended up with 2 squared, which is 4, and then minus 1, right? Okay, that's perfectly fine. But then some of us did this. Oh, okay, so this is 4 minus 1, so it's 3. Is that right or is that wrong? That is wrong. We just talked about that. Why can't we subtract this? Because order of operations say, well, you got to multiply this a and a 4 first, which we can't. That's just a, so you can't subtract that. Even if I did this, instead of a times 4, I call it 4a because that's the same, right? That's 4a. You guys agree? It's the same. 4a minus 1. And if I said, okay, let's solve for a, you would never go, oh, 4 minus 1 is 3. You wouldn't do that, would you? So we can't. We can't do that. Just like my example that said if we had, I don't even know what I did as my example. Would I have that? 5 minus 3 times, yeah, 4, right? You can't go 5 minus 3. Right? Order of operations, you have to do that first. Okay, so let's go back. So from this step, what do we have to do to solve it? Add 1. There you go, just like you do there. Add 1. Okay, so add 1, add 1. So you have 5 equals 4a. Now divide by 4. Divide by 4. So a is equal to 5/4. I know a few of you guys got that. Most did not. But now do we know? Now do we know how to do this? That's the important thing. Okay? You think something like this might be on a test or quiz? You bet. But we know how to do it now, though, right? Okay. So if I give you another problem right now, you'd be able to do it?
Yeah.
Good, I hope so. So then your answer, as far as our equation, it's y equals 5/4. 5/4, what do we get? X plus 3 squared minus 1. There's our parabola. Oops, sorry. That's our parabola. Okay? So that's how we do parabolas. All right. Okay, and actually domain and range. Domain is every x value has a graph, so negative infinity to infinity. Our range of heights, what's the lowest this gets? -1. And do we include, is there a height of -1? There is. So square bracket, -1, all the way up to, it goes way up there, to positive infinity. So that's our range. Okay? Got to know this stuff for the quiz coming up and the test. All right, let's go. So we know how to do a line. Pick any point. Here's our parabola. Just a little arithmetic there. We've got to make sure we do that right. Okay, then this thing. Well, the exponential. Let's write the equation of the exponential. Well, one of the things that's different is the starting point. Where does it normally start? 0, 1. Right there. Okay, then we can figure out, just by looking at it, how it shifts. So here, this is the starting point. Okay, not this one, but this one right there. So to go from there, where my pencil is, to there, it looks like it goes left 1, down 1, 2, 3, 4, 5. Okay, left 1 from the starting point, which is 0, 1, left 1, down 5. So y is equal to b, we'll get that in a second, left 1. So how do I write that? X plus, b to the x plus 1, and then down 5, right? Now we just have to find the b. How do we do that? There you go. Count the spaces. Remember, count the spaces. That's our trick. Well, how do we count the space? What does it mean, count the spaces? Okay, space there to there. How many spaces is that? 1, 7? 1, 2, 3, 4, 5, 6. Okay, so that's 7. And then what do we do? Add 1. So that's 8. So is that our base? No. Then we count the spaces this way. What's the spaces this way? 1, 2, 3. This, so horizontally, 3. So what does that 3 tell us? Cubed root. If that was a space of 2, square root. It's 4 spaces, 4th root, right? So 3. So cube root of 8 is 2. 2 times 2 times 2 is 8. Okay, there's our equation. Y equals, that's our base, 2 to the x plus 1 and then minus 5. That's how you do your exponential. Okay? You could do every single one just like that. We know how to shift it, and we know how to count the spaces. So I can't give you a difficult one because you do the same thing. Right? Okay, let's do a couple more here. Well, a line, there you go. This is x equals, it's vertical. X equals what? Negative 3. X equals negative 3, because everywhere on this line, x is negative 3. There you go. Okay. All right, let's do a absolute value. Let's do number 5. Okay, so y is equal to, well, what's the slope of our v? Or what's the a value in front of it? 1, 2, 3 over 2. Yeah, so negative 3 over 2. But you might be thinking, well, wait a second. If I went from this side, it's up 3 over 2. It'd be positive 3 over 2. But, yeah, there you go. The v opens down. We know it's negative, the a. So it's negative 3 over 2. That's our slope. Anytime you see a straight line, think slope. It's rise over run. And then we just do the shift, which we can all do, right? So from the origin, this goes how many to the left or right? Right. 3 up 5. So right 3 up 5. So that's x minus 3 plus 5. There you go. Okay, although I know we could do number 6, turn it over. 58, perfect. Okay. I want you to do number 7. It's the last one we're doing here. Do number 7 on your own. We should be able to do this now because we all know order of operations. So, and then maybe I'll have someone actually come up to the podium here and actually do it for us. Random call. Okay. Do the shift. Hit A. You can look at how we did the other one if you want. Confidence in you guys. Fingers crossed. Or rather, fingers crossed. Believe it or not, my toes are crossed. Gotta get our correct page. I don't know what the answer is right now because I didn't work it out. Someone's going to help us. it's a gravel, like a curve, don't do right of the lane. It's only if it's a straight line, like a V or a straight line. So you can't do straight line. So this is where. Okay. This thing's right. No, I didn't work it out yet. Okay. Okay. We got 3 minutes. Okay. Well, for sake of time, I won't have you come up here, but I'll call on someone to. Any volunteers to help? Oh, Kennedy. Would you? So what did you do?
Okay, so I did y equals a parentheses x minus 4 squared plus 6.
You got it. Good.
And then I did negative 6 equals a.
Okay, so good. So you picked this point, which was at 2 comma negative 6, right?
Yes, I did negative 6 equals a.
Good.
2 minus 4 squared plus
Good.
6.
Good.
And then I solved it.
You solved it. So negative 6 equals a times negative 2 squared is 4 plus 6. Great.
And then I got negative 3 for a.
Good. From here, okay, stop right there. Don't add that. That's not 10, whatever. Subtract 6. Subtract 6. That's negative 12 equals a times 4.
And then you add.
Good. Excellent. A is equal to negative 3. So the equation y equals negative 3 x minus 4 squared plus 6. That's the equation. That's the equation. Half of us got that. You're coming around. So we still got to make sure we know how to do this. We'll practice more. Okay, your assignment is worksheet 3 in your packet. Okay, 1-3. Okay? And up.